Okay, our next panel coming up will cover the subject of SOC modules versus embedded modems. And that session is going to be moderated by my good friend and colleague, Fred Yentz. Fred is the principal at IoT Launch, as well as Tartabit, well known in the industry. Fred, please join us. Welcome.
Thanks, Keith. If I could get my panelists to come up, that'd be great. So while they're making their way forward, what's interesting about embedded world, and I've been an embedded world fan for a very long time, many of you are designing products in systems and subsystems, and you don't necessarily know where your end markets are going to be yet, or who's going to adopt, or what enterprises are going to connect. So as you're learning and headed towards designing for connectivity, you're going to see that you have some pretty interesting options. And what might appear less expensive or easy may not be always what it seems. So today's panel, as Keith said, it's when you're designing an embedded connected asset, do I start with bigger building blocks or do I do chips on boards? And I can't forget about embedded software either. So there's lots of things to consider. And we've got an expert panel here to really take us through all those things. So I'd like each of you to introduce yourselves quickly. And then we're going to go through one slide each, because I know usually it's a technical audience and they want to see a little bit about what these companies really do. And then we'll get into a discussion. So Guillaume, Zeljko, and Paul, if we could, I don't know, found it. So Keyfactor is up.
Okay, thank you. Hi everyone. So I'm Guillaume from Keyfactor. We're a software vendor in cybersecurity. So you might ask yourself what I'm doing here on that panel discussion, but you'll find out. So Keyfactor sells software so that our customers can establish their private public infrastructure. So if you're not familiar with that concept, come to us after that discussion. Certificate lifecycle management, 8509 certificate for security, securing TLS channels between devices or devices and servers. And the third software that we sell, software that allows our customers to sign documents, sign firmware, sign secure boots, sign software. And at Keyfactor, I work on the IoT team, so at least I have that understandable by everyone, as a director for business strategy.
Thank you. A quick introduction in Quectel and your role in this space.
Thanks, Fred. So we are the global supplier into the IoT space. We're actually the market leader when it comes to cellular modems. So when I say cellular modems, everything that goes from very low end LTE narrowband, Cat-M, Cat-1, all the way up to 5G RedCap nowadays. On top of that, we have, of course, a bunch of products for the automotive market, right? But we also tackle the smart mobile devices, which are highly embedded, highly capable CPU devices, right? We also able to do the edge computing, the AI as well. We also, apart from the cellular communication, nowadays enter into the short range. So we have a bunch of devices around Wi-Fi and Bluetooth, all the way from Wi-Fi 4 to Wi-Fi 7, and so on and so on. We do GNSS as well. We do satellite, and of course, the last bit of a hardware here is around the antenna. So basically, we can supply a huge pack of hardware devices, which typically IoT integrators really need when they build their stuff. We do build a little bit on the services, but that's very complicated to explain. So I will, for the sake of time, I'll skip that one. What I do here in the company, I'm a product manager for the smart mobile product line, and that's it.
Thank you very much. And then you need to put it all together, and Paul can tell us a little bit about Eseye.
Thank you. My name's Paul Marshall. I'm a Chief Customer Officer and a founder at Eseye, and we provide cellular connectivity services for IoT devices around the globe. But the key about the cellular that we supply is it's managed services, so we make sure the device gets connected. And that's where we get the triangle here for the three things. So if I start over on the left-hand side of the slide, we've got interconnects with multiple network operators around the globe and data centers in different locations, which means that we can meet the data sovereignty requirements when people are delivering IoT data into local cloud or even local data centers. We also have to get involved, we delight in getting involved in the hardware as well. And actually how people put IoT devices together really matters to us. So we've got a number of things. One of the things that we're showing on the stand today is the Hera 200, which is a IoT gateway, gives Ethernet out connection for IoT devices like EV chargers, things like that. So we actually have those as products that we build. We also do bespoke designs for customers, but one of the things that we do make available for people to use is software we call Smart Connect. And this is software that we've written. It actually loads onto some of the Quectel modules, like the BG95 or the EG21, EG25. So it allows customers to get over that hurdle of having to write the same piece of software to get connected every single time, but instead actually use that to say, this will connect my application, now I just want to get my data in the cloud. And of course that takes me to the final part, which is actually we're providing managed connectivity, but how do our customers see that connectivity? How do they see that happening? And that's where we provide our single platform. So no matter which of those network operators we're using, however we are routing the data, customers get that single pane of glass and control through that single Infinity platform. Thank you.
All right, so you made it sound real easy. That's my job. It's your job. So before we start, just a quick question to the audience. How many in the audience have actually implemented cellular products, cellular-enabled products? A few of you. And I know some of you are suppliers of the technology. But when we think about how customers in the embedded or the product space embark on their journey of wide area, cellular, and other connectivity, it's probably going to deviate from what you have done in the past, which might have been Bluetooth connected or potentially Ethernet connected, where you put a couple chips on the board. Things are pretty simple. And I'm going to start with Quectel. So the idea here is, do I do modules in bigger pieces or do I do chips on boards? And talk about the advantages and the disadvantages. And the first one people will talk about is the economics. They think it might be cheaper to buy chips and put them on a board versus buying a highly integrated module.
Yeah, I know that's a typical way of thinking, but in reality, it's not the case, right? Designing such a module, and even a smart module and as a whole, it's a very complex and lengthy process, right? And today, if you want to be very successful with your business, you have to be either fast, you have to be innovative, and you have to be cheap, right? If that's possible. And buying basically a module and not building a chip-on-board solution really improves the time to market, right? You really speed up development. And what I also like to say, you get a hassle-free development here because you get fully designed in and certified product, which is one of the key things to get a successful design in at the application, right? You can really be focused at what you're really good at, and that's the application itself, right? Not designing a model, right?
So that was a leading question. We know it's really not cost. There's a lot of other factors to cost. And when we think about a fully integrated module, there's an enormous amount of embedded software that goes into making all of these components work if you start putting things on the board. So Guillaume, could you talk a little bit about how you play and what are some cautionary tales you might have for customers?
A cellular modem is a complex system, very complex subsystem. You have to address many bands, many geographies, many countries, many regulations. You have to comply with many laws. And sometimes to get also certification by operators. So the software that will run on those chipsets, if you do that by yourself, or if you take that software and you want to integrate that, by essence, it's difficult. But there's more to that. As you know, in Europe, there's the Cyber Resilience Act, which is coming, and which will come into force in October, where every OEM will have responsibility for the cybersecurity of the device or the machine that they will put on the market, and that for the life of that device or machine. Which means that OEM will be responsible to list and report software vulnerabilities into its device or into its machine. And we'll have to fix those vulnerabilities for free when that device, that machine is used by maybe a customer of that company. So the cost of maybe assembling software pieces that you will have to collect from different suppliers. So the cellular stack and maybe a TLS stack to do security, and maybe to implement a proper secure boot on that modem. And of course, those chipset manufacturers like Qualcomm, for instance, they will come with updates of the stack over the years to follow the advances into the standards of the GSMA standards, or maybe some regulations. So you will have a responsibility to put in place what it takes to update that firmware and that software in addition to your application securely over the air. So all those mechanisms of secure boot, secure update over the air of that firmware and that software layers, which is very complex into a modem, if you do that by yourself, it's not easy. And if you buy a modem from a provider that already has implemented everything, that has certified everything, and that provides you with a secure boot mechanism, which is guaranteed by the modem manufacturer, some of them even provide you with firmware update services, mechanisms for the modem, maybe for your application. It's something that has a lot of value, especially with that CRA coming into force in October.
So it isn't really easy to do it yourself.
No, it's not easy.
Okay,
It's
just
doable, it's not easy, but you need to have the right people and you need to spend money on that. So it's not only the cost of the chipset, the cost of the hardware, the cost of manufacturing on the PCB, the cost of the antenna, it's all the rest, which deals with cybersecurity and maintenance of that modem and maybe what's built around the modem.
So if we think about maybe some of the most critical resources out there is skilled labor in the labor pool and experience. So we've got a guy that does a lot of this stuff, right? Paul, you put pieces together, you put networks together, put solutions together. You've got a lot of experience, your company's got a lot of experience. Would you embark on a chip down big design, or do you typically leverage the module kind of an approach? And from a practical experience, what do you think?
So I think for most customers, going for a module approach is exactly the right answer. And exactly as we were talking about, it's things like, you were talking about time to market. Actually, everything wraps around, I think, the business case. Engineers don't always like to hear it, but it's the business case. And actually, to make that business really work, time to market really is critical. If you're going to lay out a chipset and do that work and get it certified and meet all those standards, then that's going to increase your project significantly. So being able to do that is really important. The other thing I think which drives towards this is actually reliability. Again, if you're working with something, a module which is pre-built, that has been designed, it's been tested for reliability, particularly in corner cases. We're talking about IoT devices which aren't like a cell phone. The IoT device is probably going to be concreted in the ground somewhere, very inconvenient. If you've got a device that basically it's almost impossible to get to, and even if you could get to, it's going to cost you hundreds of dollars, that is going to take it completely out of any useful business case. So reliability really matters. And therefore, actually having a module helps with that. And the other part we talked about was security, which is saying, how do I get my application data securely to the cloud? And I think these are the three things that are going to make a successful project. And the modules deliver that.
What I wanted to just add, basically, the partnership is the key, right? You can do everything on your own, but it will take you ages, right? You can do the hardware design, you can do the software design, you can do the certificates, you can do the security as well, everything you can do, right? But can you really have in your company expert for all of these topics? No way. Nowadays, basically, if you look at the classical company, they cannot afford to have 10 hardware engineers. They basically do one design, two designs in 2 or 3 years. And then basically they just do the software maintenance a little bit. They don't really want to design even the hardware of the application. And we talk about the model, which is just one component in the whole hardware, right? So I think partnering is really one of the key to success in this business.
I mean, I think that's really exciting because we talk about customers, again, lots of the projects that we work with, customers we work with, they're moving from a model where they were building product and selling product to connected devices and maybe having services. And that means actually they're moving into an area where in-house they don't have that expertise because IoT expertise is still very rare to get hold of. And therefore being able to use something which is pre-built, whether it's the security, whether it's the module, or even some of the software components, actually that really helps people, that time to market quicker. And I see the successful projects are the ones where people, they've got the idea and they can take it to market quickly.
Okay, so your time to market, understand. But I think the other thing that's interesting is the life cycle of these products and the support. if you're in, there's phenomenal chip makers out there. As a matter of fact, they sell their chips to the module makers. So their customers are the module makers. So when you look at the Qualcomms of the world or the Sonys of the world, they are used to connecting with and talking and working with very large established engineering teams. And if you're a small engineering team, one, you probably won't get their attention. Talk about how that support works, because things change, firmware changes. This is not a static environment in which we live.
Absolutely, absolutely. The network enrollments are constant changes in the networks, are constant, not only change between the 2G, 3G, 4G to 5G, also within the 4G you have, of course, multiple releases. Every release brings new functionalities, right? And you need to be able to cope that. So the first thing is, how many people have that knowledge? I would say only a few. In a company of ours, which we are 6,000 people already, I can name maybe 10 people that have such a knowledge. Can a company of 100 really afford that? I don't really think so. And then again, of course, when it comes to cellular connectivity, you need to have the labs. You need to have things at your premises which you can use to basically test your devices, which not everybody can afford. It takes a lot of space. It's a lot of money to invest into that knowledge and the equipment to be able to do that. And of course, the maintenance is one of the key points, right? I mean, first of all, a small supplier will never have a chance to talk to Qualcomm, Intel, whoever, right? If you think you're big with your 10,000, 50,000, think about it, their key customers are mobile phone makers. They do millions, right? Maybe in the automotive industry you will find big ones as well, but in IoT, I don't think so, right? And then imagine, can they really support all of these tens of thousands of customers? Not really. That's the reason why they have us as a module integrators, right? We are the ones that have a global structure, right? We have the big R&Ds on the several continents. We have a regional guys, regional FAs, regional sales. So in order to provide a very quick support, right, in order to solve all of these problems. So this all sums up as a key topic when it comes to the maintenance of the devices, right, which is really a huge topic indeed, yeah.
So in maintenance of an IoT device is an over-the-air firmware update. We don't ever want to roll a truck, right? And when we're pushing code out there, we want to make sure we've got secure, trusted endpoints. That's where you play. When we think about next steps and we think about policies and regulations changing, and you were talking about the cyber trust mark and some other things that are coming along, what other things might an audience be concerned about in terms of kind of regulatory and security? Because it's on everybody's mind. That's something that a lot of people didn't really worry about in IoT 5 or 10 years ago. We should have been worried about it, but it was kind of a dirty little secret that things were connected and they were not necessarily acknowledged as an IT threat. Now they're all surfaces of threat, quite frankly. So give us some up.
Yeah, sure. So the more you connect, the more you expose yourself to threats and attacks. And of course, here we're talking about connected devices. So I suppose that the way it's going is that the OEM will have more and more responsibility. I think we polled the industry, when was that, Hélène? In July last year, we polled 1,500 partners, prospects and customers, both OEMs and service providers, operators, and we asked them where they thought the responsibility should be between the OEM and the service provider for a faulty device in terms of security. Who should be first responsible for the security of a device and machine? And they responded, I think 75% responded that the responsibility was mostly for the OEM. So sometimes it's a shared responsibility. For instance, your service provider, your OEM is publishing a new firmware update, and of course, they're not applying it. You're owning the device, you're owning the smart meter, your utility, you're owning the smart meter. So it's your responsibility to upgrade the smart meters with the firmware update. If you don't do it, you don't do it, and you're taking responsibility for that. The smart meter manufacturer cannot be blamed for that because they informed you that there was that new firmware to push into the devices, and you did not do it for good reasons, hopefully. But so sometimes it's a shared responsibility, but mostly the OEM is responsible. So our piece of advice is always, when designing complex systems, don't add complexity to your own design. And I think you're right. You cannot compete with modem manufacturers who manufacture millions of modems, get them deployed and used all over the world. So they have instant feedback from customers from various regions. And I've been there using those modems and testing them, and there are always gaps. So I've even worked with Quectel, and I've been in touch with their support to ask for auto BIP support, for support of SGP 0. Yes. So regulations, standards evolve constantly, and doing that yourself, I mean, you would have to be a very, very big company to be able to afford that effort and that team to maintain your device up to date with those regulations and standards. And security, of course.
Just to add what you said, I mean, with the Android devices that we have, we release basically on a quarterly basis a software update to deal with all the security Google bulletin, right? And you need to have a technology to download the latest software, and you need to do it securely, and this is where actually the perfect play. Yeah?
Yeah, I mean, I think we're talking about downloading software to make sure the modem and the modem chipsets are actually fully up to date. And I think one of the things that module manufacturers can do is provide the tools to be able to do that. Whereas again, if you've got like a homebrew modem, if you like, then actually you've got to build all those tools yourself. And those are the real challenges. Whereas actually finding that the module manufacturer has got the latest version available, all you need to do is issue the commands to get it. That's exactly the right solution.
So the title of the presentation was a little bit of a setup. If you're in the embedded world, you're probably doing some reasonably high, but not mega high volumes. If you're not a mega high volume and a very, very large engineering shop, you probably want to stick to a supply chain that was designed to deliver the highest level of reliability and service and engineering support that you can. And when we think about, you know, the embedded world, typical clientele and you guys, some of you ship to a very niche end market. Some of you ship to some very specific geographies, your products, but your customers might have a world presence. There's a different problem if you ship 1 million devices into Germany versus 10 devices into 180 different countries, right? The countries, the networks, share a little bit about kind of the complexity of a global deployment, because sometimes an embedded engineer might not think of that because they're thinking of the first deployment, not necessarily all of the deployments.
I think that's a really interesting point, because actually a lot of the projects that we see, an engineer's got the device working brilliantly on their bench. They're pretty much 100% connectivity. Every time they do something, it works. They take it into the field, and the first time they take it into the field, something goes wrong, it falls over, and it drops their data. And actually, that's just taking it, 10 miles down the road, 100 kilometers down the road. Once you start going into different geographies, you're talking about different networks that have implemented the networks in slightly different ways. And especially if we go into some of the LP-WAN solutions, like Cat-M1, NB-IoT, where there are a number of options that the network implementers can put in place. Which versions of power saving do they use, and how do they do those? And all of a sudden, what you find is a design which worked brilliantly in one country, you have challenges in another country. But of course, coming back to modules or designing it yourself, one of the things that is really interesting, when people go around the world, we see our customers fall into two completely different groups, and both for really good reasons. Some customers use a global spec modem. So they take the global variant of the modem, it can scan all the bands, it can connect to all the bands, it's got all the compliances for around the world. We have other, and therefore they say we can build once, have a single SKU, and it works anywhere. I love those because, of course, the SIM connectivity that we supply is a single SIM that works anywhere. So it works really neatly together. But what we also see is customers who say, to reduce my costs, I'm going to buy the European version of the modem and certify that in Europe, and the US version of the modem and certify that in the US. And, of course, that can work well for them too, but it means they have to have two product lines. Now, I can still serve them, so I'm quite happy. But what's interesting is if you're going to design it yourself, you've suddenly doubled your design effort, because you've got to have a local variant for the US, and you've got to have a local variant for Europe, and then that ties back into the security, because the US have got different rules against Europe, and therefore you're doubling everything, all the certifications, all those testing. And I think those are real challenges to projects if they go down that route.
A very good point, actually, just to add on top of that, you tackle basically the network compatibility, which is huge topic, but then again, also linked to the price and so on. There are companies that are doing, let's say, devices on LT Cat 1 technologies. Tomorrow they need something completely different. Maybe they need narrowband, maybe they need 5G. Do you really think that small companies can really master these technologies? No way. Such a shifts are huge. It's not just hardware, it's software, it's certification, as you said, field testing, everything.
So the reason you're here is IMC, the IoT MDM Council. And what do? We're here to create an ecosystem of buyers and sellers. And what you're seeing members of IMC who represent basically the value chain to you, the engineers who want to implement. And part of what we do is we make sure that we get time to network and ask questions. So instead of passing a microphone around and trying to get you to publicly ask a question, I would encourage you to attack and ask any questions you like of these folks while you're drinking a beverage or enjoying a cocktail. And I want to thank my expert panelists. You've been there, you've done that, you've stepped in the snake pits already. Wisdom is a wonderful thing, and to share it so people don't make the same mistakes, I think is stellar. So any last comments, and we'll call this done. Any closing comments?
Yeah, sure. I think we mentioned Bluetooth or Wi-Fi at the beginning of that session. So the choice between a chipset design and a module design for Bluetooth is maybe a volume around 10K units a year, something like this. Above 10K, you would probably try to go for a chipset. Cellular, never. It's my piece of advice. Never do that.
Okay.
I think basically we just scratched the surface here. This is such a complex topic, and we can debate about it really long. So I'm actually in a whole 3 on across the 3. So I'm the whole day tomorrow. If you want to continue this discussion, I'll be there, and let's meet up.
Paul?
I think you're right, we've just scratched the surface, but I would say, we've had a show of hands of people who've implemented cellular IoT projects. I would say that there are some real challenges there. So, work with people that have done it before, work with people that know how to do it, but build cellular connected products, because actually they can transform a business and really add value to the customers.
Yeah, focus on the problem at hand, which is growing an IoT business, not growing an IoT engineering competency to do the things that other people already do well. So thank you all.
You put that really well.
Thank you all, and have a wonderful reception.
Thank you.